Number 4, 5, and 6, we are graphing an absolute value function. A normal graph of an absolute value function looks like a V, and the vertex is at 0, 0. That's if you don't have any horizontal or vertical shifts. If you have adding and subtracting, you're going to have horizontal and vertical shifts. The end number shifts the graph up or down, in this case down 3. The number in with the x kind of does the opposite because you have to set it equal to 0. So if x plus 4 equals 0, x equals negative 4. So that actually is going to shift it to the left 4 places. So in my table of values, my vertex is going to be at negative 4, negative 3. Now in Alex, they're only going to make you do 1 point on each side of that. So we're going to put negative 3 and negative 5 in for our other 2 points. And then basically we're just going to substitute it in and solve. So negative 3 plus 4 is going to give you 1. The absolute value of 1 is still 1. 1 times 2 is 2. 2 minus 3, negative 1. Now when I do the negative 5, I should get the same answer in order for it to look like a V. Negative 5 plus 4 is negative 1, but the absolute value of negative 1 becomes positive 1. 1 times 2 is 2, and 2 minus 3, negative 1. So negative 4, negative 3 is where my vertex is. And I have a point at negative 3, negative 1, and negative 5, negative 1. When you draw this on Alex, you're going to have to use the ruler and draw 2 separate lines. You want to draw from the vertex through the end point. It doesn't like it if you stop right on the end point, and it doesn't like it if you go past your vertex. Then you'll set the ruler on the vertex and the other end point, and again, just make sure you draw all the way through that end point. Don't stop on it. It doesn't like that for some reason. So my graph looks something sort of like that. So an absolute value function always looks like a V when you graph it. Or if you're looking at a graph and it looks like a V, you know it was an absolute value. I lost my problems. 5, that'd be where we're at. So if I look at the next one, we have negative 2 times the absolute value of x minus 1 minus 3. My vertex, the x value would be at 1 and negative 3 would be my vertex. So 1 minus 1 would make that 0, and then if that's 0, the y value ends up being negative 3. But we'll talk about horizontal and vertical shifts. Shifts to the right 1 and down 3. So I have to go 0 and 2 to get 2 points right on each side of that 1. If I put 0 in there, 0 minus 1 is negative 1. The absolute value of negative 1 becomes positive 1. 1 times negative 2 is negative 2. Negative 2 minus 3, negative 5. And if I put my 2 in there, 2 minus 1 is 1. The absolute value of 1 stays 1. 1 times negative 2 is negative 2, and negative 2 minus 3, negative 5. So 1 and negative 3 is my vertex, and then 0, negative 5, and 2, negative 5 would be my other 2 points. And I'm going to draw from my vertex through each of my endpoints. And later we'll talk about reflecting, but since there's a negative coefficient in front of my x's, that flipped it across the x-axis, and that's why my V is upside down. Just stay where it's supposed to. So number 6, if you look at that, your vertex is going to be at negative 3, positive 4. So negative 2 and negative 4. So if you put negative 2 in there, you would get a y value of 7, yep. And if you put negative 4 in there, you're also going to get a y value of 7. So negative 3 up 4, negative 2 is up to 7, and negative 4 is also up to 7. And then we can draw our absolute value function.